Today, we will see how can we rationalize the denominator. Now, the main idea here is that we are going to use something that is called a conjugate to rationalize the denominator. So first, we will talk about what a conjugate is. And once we have a clear understanding of what the conjugate is, then we're going to use that conjugate to rationalize the denominator, which is our main goal. So keep that in mind. First, we're going to talk about something called a conjugate, and we're going to use the conjugate to rationalize the denominator. So let's get started. Now here, let's talk about the conjugate first. One thing to keep in mind is that when you multiply by the conjugate, you will cancel out radicals. Or again, radicals is another way to just say square roots. So now, what is the conjugate? Well, the conjugate is just a fancy word, and this is what it means. When we're dealing with square roots, which in this case, expressions that have square roots, the conjugate is just going to be, you're going to switch the sign between the two terms. So if this is your original expression, your conjugate is just going to be 5 plus 6. And that's it. This is the conjugate of the first example. All we're doing here, the conjugate, you just switch the sign of the term between them two. So here's another example. 2, let's find the conjugate of 2 plus square root of 3. Again, the conjugate of 2 plus square root of 3, that would be 2 minus square root of 3. This is how we can find the conjugate. You're basically just switching the sign between the two. So let's just find another conjugate real quick. The conjugate for C is pretty much the same expression, but you're going to switch the sign between them. So instead of a plus, it becomes a minus. So this is what a conjugate is. Now, why is a conjugate pretty important? Well, let's just show that on the first example. Let's get the expression and let's multiply by the conjugate. So now, let's see why the conjugate is kind of important. So we have the original here, square root of 5 minus 6. Let's multiply that by the square root of 5 plus 6. So now I'm going to do the multiplication a bit fast because you should be familiar with it. So 5 times square root of 5 times square root of 5, 25, where the square root of 25 is just 5. Square root of 5 times 6, that's equal to just 6 square root of 5. Negative 6 times square root of 5, that is equal to negative 6 square root of 5. Don't know what's going on with those 5s. Excellent. And negative 6 times positive 6, that's equal to just negative 36. Now notice what's going to happen here with the square roots. They will cancel out because you have positive 6 square root of 5 minus 6 square root of 5. They will cancel out. Then you can just combine like terms here. So now this becomes negative 31. I'm not going to do this for all the examples here, but I want you to notice that every time we multiply an expression times its conjugate, the square root, it will always cancel out. So that's why the conjugate is important. But now, let's talk about the main idea for today, which is rationalizing the denominator. So here, on the first example, they're asking us to rationalize the denominator. Now, what do we mean by rationalizing the denominator? In mathematics, most of the time, you should never have a square root as your denominator. So somehow, we need to write an equivalent expression of this, but without the square root on the bottom. So there's different ways to do it. Now, when you just have one square root or you just have one term on the denominator, all you gotta do, you gotta multiply by the square root top and bottom. Square root of 6 is what you need to get rid of because you don't want any square root on the denominator. So what you're going to do is just going to multiply square root of 6 top and bottom. So now that we have this, let's actually perform the multiplication now. So now we're going to have square root of 3 times 6. And that's going to give us exactly, you know that when you multiply square roots, you just multiply the insides. So 6 times 3, that's 18. So we're going to have square root of 18. And we're going to distribute this again. So 9 times square root of 6. Negative times a positive, that's a negative. 9 times square root of 6, that is equal to 9 square root of 6. Excellent. So we're done with the numerator. So now we got to distribute this again, but now in the denominator. So now we're going to multiply this whole thing, because that's just one term, times the square root of 6. And that's going to become 2. And you multiply the 2 square roots, so that'll be 6 times 6. Well, let's see. Can we simplify anything? Well, let's perform the multiplication now. So now this becomes 2 times the square root of 6 times 6, that's 36. But we know that the square root of 36, that's equal to just 6. So nothing changes. So now this becomes 2 times 6, where 2 times 6, that's equal to just 12. And notice that in our final answer, there is no square root on the denominator. So this is a clear indicator that we're done with our problem, because we rationalized the denominator. We rewrote the same expression without a square root on the denominator. So now let's take a look at another example here. Notice that example 2 is a little bit different, because in example 1, we just had one term on the denominator. But now in example 2, we have 2 terms on the denominator. So what can we do about it? Again, still, your main idea is to get rid of the square root that is on the denominator. So when you have two terms, we don't just going to multiply by square root of 3 top and bottom, just like we did on example 1. But when you have two terms, we're going to multiply by the conjugate top and bottom. Let's write that in red. So what is the conjugate of square root of 3 minus 5? Well, that's going to be square root of 3 plus 5. We saw what a conjugate was on the previous slide, which is pretty much just the same expression. You just change the sign. And now that we have this, then we can multiply now. So now let's see. 2 times square root of 3. That's going to give us 2 square root of 3. So that's excellent. So now we're going to have 2 times 5. So now that becomes just 10. So we're done with the numerator. Now here comes a good part, which is the denominator. You're going to multiply square root of 3 minus 5 times square root of 3 plus 5. So how can we do that? Well, let's perform the multiplication now. Square root of 3 times square root of 3, that's equal to just square root of 9. Square root of 3 times 5, that's equal to 5 square root of 3. Okay, that's excellent. So we're done distributing that square root of 3. Now we need to distribute this negative 5. So now this becomes negative 5 times square root of 3. So now that becomes negative 5 square root of 3. We're not done yet. So now we need to distribute negative 5 times positive 5. So that's equal to negative 25. That's good. Okay, so now let's see. What do you notice in the denominator here? Notice here that the square roots are going to cancel out. 5 square roots of 3 minus 5 square roots of 3, they will cancel out, because anything subtracted by itself, it's always 0. And notice that square root of 9 is just 3. So let's just rewrite this as just 2 square roots of 3 plus 10. divided by square root of 9 is 3 minus 25. We can simplify the denominator still. We can simplify it as 2 square roots of 3 plus 10 divided by negative 22. Because 3 minus 25, that's equals to negative 22. You do not have a square root on the denominator, so you know that you're done here. Let's just take another example here. Example 3. Excellent. So again, you want to get rid of those square roots on the denominator. If you have two terms, what you do is you multiply the conjugate top and bottom. So let's multiply by the conjugate top and bottom. So now this time the conjugate is going to be square root of 5. If you have a plus, you change it to a minus. So minus 3 divided by square root of 5 minus square root of 3. Excellent. So now here comes the fun part, which is just distributing. So now we're going to have this. Square root of 15 times 5. Well, this is the same as 15 times 5 minus square root of 15 times negative 3. I'm sorry, square root of 15 minus square root of 3. So that is equal to just negative square root of 15 times 3. So we're done multiplying the numerator. So now we need to distribute the denominator now. So square root of 5 times square root of 5. This is equal to square root of 25. Square root of 5 times negative square root of 3. So that's negative square roots of 15. Because again, when you multiply square roots, you pretty much just multiply the insides. So now we have the square root of 3 times positive square root of 5. So now that becomes just square root of 15 positive. That's what we just did here. And square root of 3 times negative square root of 3, that's equal to just negative square roots of 9. Yeah, I don't know why I didn't write the multiplication here, so let's just rewrite it. So 15 times 5, that's equal to just positive 60. So let's just rewrite that. And 15 times 3, that is equal to just, what's that? 15, 30, 45. Sorry about that. You can just multiply the numbers straight. There's no, so you cannot have any confusion here. All right, excellent. But what do you notice about the square roots again here on the denominator? Negative square root of 15 plus square root of 15, they will cancel out. So now look at the numerator here. So now we have 60 minus square root of 45 divided by square root of 25, this is just 5, minus square root of 3, so that's minus 3. And let's just simplify this. So now this becomes 60 minus square root of 45, all 5 minus 3, that's just 2. And this is your final answer. Notice that you can still simplify your final answer here, but this video is just to show you the technique of rationalizing the denominator. We're not going to concentrate too much on the simplification yet. So now, here's your entrance ticket. You have the following. Try to rationalize the denominator.